Yes, hello guys. So, in this discussion, as I usually like to call it, this discussion we are going to do what? I forgot. Uh, we were creating a mixing tank, I think so. Yeah, creating tank model, and we will be doing some sort of sketching, modeling, and parameterization. Uh, So, if I give you some background, so this discussion will apply sketching, modeling, parameterization techniques to the construction of a mixing tank model. The model will be prepared for a rotating zone simulation requiring a non-conformal interference separating the spinning blade region from the outer body. Oh, it's a lots of technicalities. By the way, I cannot uh, expose the sources of this this discussion or tutorial, as you may like to call it, because it's classified. But yeah, I can share with you, and we can mm, like go along making it, but without keeping the source in mind. Okay, source is with me. So yeah, there are certain people who are like good at design, sketching, modeling, and to them there could be another part for which might specifically feature only parameterization, but here I'm focusing on both sketching, modeling, and parameterization. So in order to start, let's go first to Workbench. It's like for Ansys, and make sure you've got your desktop, or desktop needs to be always plugged in, but your laptop's always plugged in, because this is going to consume a lot of strength, a lot of stamina from your devices. And apply turbo if you have one, turbo mode in your laptop. Sorry for that, I have a bad cold. Well, no cold is a good cold. Yeah, so first, what do we need to do? We need to create a new project, as someone told me. And okay, and what is that project called? Can I have full screen over here? Yes, I can. And expand, then we need to expand our component systems and drag and drop a geometry component onto the project. Okay, so we have component systems over here as tool, and we need to drag and drop geometry here. We see, we double click on the geometry cell A2 to start design modeler. Okay, double click here, and let's wait for it to get back to life. Uh-huh. I hope they have not forgotten that I have asked, I've given a command. Is it already in progress? Yeah, okay. Now let's open space claim. Double click on geometry cell to start design modeler. It should have opened design modeler, but if it has for some reasons open space claim. I don't know why. Uh, no, let's right click on it. Edit geometry in design modeler. Whoa, that could not be done. And if I just simply close space claim and then maybe retry, yeah, new design modeler geometry. So some things in my sources are also wrong. That's why I'm not sharing those with you. See, it is very easy. So in this session, we will be using millimeter, and for that we will go to select and don't see select units, millimeter. Okay, yeah, millimeters. Okay, everything is in millimeter now. Micrometer, foot, inch. Okay, degree, radian. So planning. Everything requires a planning. No one is exempted from that. We'll create a simple planning. To start, we need to create a simple sketch. The sketch will be extruded later to form a single blade. The sketch will be dimensioned to allow the blade angle and to change it as a parameter. This looks something interesting. Sketch creation. Create a sketch in the tree outline. Select the XY plane. Okay, we got an XY plane over here. And click on the look at button in the toolbar. Yeah, it's a very important button, and for some reason I'm not seeing it. Now I'm seeing it. Okay, I'm looking at the XY plane. Okay, select the sketching tab mode. Sketching tab mode. Okay, I am in the sketching tab mode. Draw and create a blade sketch. Select the line tool. Draw a line the y across the y-axis by clicking once on the left of the axis and again on the right. Position is it only approximately as shown, and that is what I'm going to show. It actually has, it's something like this. I think I have drawn it the more or less the way it was supposed to be. uh, Create the plate. Now select the modify toolbox. Whoa, okay, I've got here modify, and make sure, okay, select the split tool. What do we see? Okay, split tool, we select it. Make sure it is set to split at select. Yes, it is set to split at select. If not, right click on the graphics window and select. Okay, right click on the graphics window. Now where is the graphics window? Yeah, see, uh, if that's not the case in your system, maybe you can use this. You just right click in the space where we are drawing things, and you can split edges on different commands. Okay, make sure it is set to split head select, which it is. If not, right click on. Okay, yeah, I've already read that. Split the edge by clicking approximately where shown. Okay, so it is shown something here, so I just click over here, and okay, from the constraint, the next step is from the constraint toolbox, select the coincident tool. Where is the constraints toolbox? Coincident. Yeah, I've seen it. Select the vertex. Okay, select the new vertex where you split the edge in the previous step. Select the new vertex. Select the y-axis. The edge will move such that the vertex is coincident with the axis. Okay, let's see how this thing works. So they are asking me to select the point where the point that we made while splitting the edge, if I recall it correctly. uh, Click on the that edge and then the y-axis, and yeah, okay, it makes it coincident. Great. Yeah, it says the edge will move such that the vertex is coincident with the axis. From the dimensions toolbox, select the general tool. We have dimension, then we have general. uh, Select the edge to the right of the axis. Okay, I select it. uh, Click to position the dimension. Okay, just do it anywhere. Okay, set the dimension to 40 mm. And how to do that, by the way? Oh, okay, yeah, from here click 40, and everything is in mm, so I type 40, and it is 40. Click to position the dimension in the blah blah blah. Okay, that's done. Now select the x-axis, select the vertex on the y-axis. Click to position the dimension and click the x-axis and the vertex on the y-axis. So now click the x-axis and the vertex on the y-axis. So yeah, and set it to 25. It's v2. Oh, fortunately I was about to get it right, but okay, that's how it should look like. Okay, in the details we set the dimension to 25 mm. I think I'm cutting my face over here. Yeah, I'm so sorry. Actually I have to sit very close to the laptop, but I think my face is not as important as what I'm demonstrating here right now. Self-deprecation. Click the create the blade, sketch continues, and from the dimension toolbox select the angle. Yeah, I was wondering why are we not setting an angle here. I could make it like any angle and it could start depropelling me instead of propelling. Okay, from the dimensions toolbox select angle, and I think so we must be setting an angle with the x-axis. That's what I'm speculating. Right click and select alternate angle until the correct angle dimension is shown, and then click to position the dimension. Select the edge to the right of the y-axis. Okay, select the x-axis. Okay, and then right click and select alternate angle until right click and select alternate angle until the correct angle dimension is shown, then click position to dimension. Okay, now A3 in the details view set it to 20°. I've set some weirdo values. Okay, is this thing right? I'm wondering. Uh, create the blade sketch continued from blah blah. Let's take some time over here. Select the x-axis, select right click and select alternate angle until the correct angle dimension is shown, then click to position the dimension. Okay, let's do it one more time. Select the edge right to the y-axis, select the x-axis, now they are asking me uh-huh. It should be something like this. Sometimes I get lost somewhere. Okay, yeah, until the I'm not able to understand until the correct angle dimension is shown, then click position the dimension. Alternate angle, do not move with geometry. Yeah, it's actually not showing what I want to see. And I really don't want to ruin this tutorial. A4 and why is it 1? What's the concept? I do it 20 and it does something else only. In the details, we set the angle dimension to 20 to set the angle dimension to 20. Uh, uh, from the constraint toolbox, select the equal length tool. So it's like saying you do anything, it does not matter. If I click then there, warning, new dimension model makes our constraint. Use cancel or undo to restore. Edit the dimension and set as reference. I don't care. I think I flipped the line over. Is this my complete line? Ah, it's 340-degree. Cancel. Can I just simply delete this stuff? Delete it and just delete it. Oh no. Okay, it comes back. Then it does something. Control Z, it's like a savior. I just want to understand this A4 thing. Uh, it's angle thing. No matter what I do, click on this and then click on this. And what the hell is happening over here? It's making a circle. Okay. Uh-huh. Something like this. Dudes, right now I'm going to set it 340 because it's 20 minus. I don't know what's happening, but yeah, let's just do it this way. Yeah. And then click the x-axis, and they have inherently shown me something like the right part of the axis, the positive part. So I don't think so I've done anything wrong, but let's not waste too much time over here. I think so we have consumed a lot of time over here. Select the edge to the right of the y-axis. We're done with that. From the constraint toolbox, now select the equal length tool. Go to constraints, select the equal length. Where the hell is that? Equal length here. Select the edge to the right of the y-axis. I see it now. Select the edge to the right of the y-axis. Select the edge to the left of the y-axis. And for some reason, okay, yeah, I just see it. The edge to the left will become constraints to be equal to the dimension edge on the right. Okay. Check the sketch and details match those as illustrated. I cannot show what is illustrated, but yeah, some problems over here. I think so. See, we need to design a propeller, and for that we need to place the pitch angle of the blade at certain angle. And I think I'm doing it the wrong way. So if someone knows how to do it, please type me in the comment section. Uh, but anyways, it's not going to kill us. L1, my L1 is 40. So for my happiness, uh, length distance, let's calculate length between these 2 points. Warning, new dimensions. And what is that? L7, it is also 40, and what that was what was supposed to happen. Dimension label window by clicking on the sketch and will respond to dimensional changes. Okay. A4. Oh, we've covered a lot. Uh, so now in the dimensions toolbox, select the animate tool. Okay. In the dimensions, click on the animate tool and so the cycles has 3. I don't know what are these cycles supposed to do, but if someone has an idea, please tell me. Click on the dimensions label in the graphics window one by one to check how the sketch will respond. Oh, okay. L1, okay. V2. Return to modeling using the tab. Okay, so right now we were doing sketching and now let's do modeling. Preparation. Planning. So now we have the simple sketch representing the blade cross section. We will create the mixing blade assembly using a series of modeling operations using active bodies initially to create one unified body. Okay, where is my mouse pointer? Yeah, it's over here. Now we will extrude the blade sketch on the tree outline. Select sketch once, select extrude. Select sketch 1 and click extrude. Okay, operation add material. Operation add material and FD1 depth as thin surface. Click it to yes. Inward and outward thickness must be 22 mm. 2. So you just type the number, it will automatically take the unit because we've already set the unit to millimeters. Now depth is 150 mm. I see the depth here, but it's FD1. Okay, I think so. It is the thing that they're. Check other details, view setting, right. Check other details, view setting. I don't know what the hell are they talking about, but click generate. Okay, yeah, I don't know. What's this? Yeah, it is something. XY plane. Okay, click generate. Now blend the blade tip. Uh, Blend the blade tip. Select the fixed radius blend from the create menu toolbar. Let us have some water. Blend the blade tip. Sometimes my mind goes somewhere else. Select fixed radius blend from the create menu toolbar. कहाँ पर है भाई ये? Blend fixed radius, yeah. Fixed radius blend. Okay. In the details view, set radius to 25 mm. FD1 25 mm. I select it. Okay. Activate the geometry selection box and select the edge filter. Okay, where is the edge filter? Yeah, I see edge filter over here. Oh, when is it clicked? Yeah, now it's clicked. Select the two short edges on the blade tip as shown. Control click for multiple selects. Okay. I'm so sorry. I generally don't use design modeler, but we are compelled here to do so. So use control to select it, and then maybe use control to select it, the other one. Apply selection in the details view. Apply the selection in the details view. Geometry, we've got two edges over here, and click generate. So what do we have over here? If I turn it, yeah, see, we've got a blend over here of 25 mm. Let's XY plane is selected and we'll look at it again. I think so design modeler is much more easier, and solid edge is also really good. Okay, now pattern. From the create menu, select pattern. From the create menu, select pattern. Yeah, we are learning a lot of commands over here, so it's yeah, it's just a journey of learning. Set pattern type to circular. And how do we do that? I think so here we do it circular. We take it okay, set pattern type to circular. Activate the geometry selection box, select the blade body and apply. Okay, so we have geometry selection box, and okay, activated to select the blade body. What do they mean by that? Select the blade body and apply the selection. uh, Select the XY plane. Activate, select the XY plane, select the blade body and apply. See, I don't know what do they mean by this, but oh, okay, it just selects all of it. Okay, now activate the axis selection box, and we select the uh, on the select the XY plane, and then the Y axis and the graphics windows are shown. Yeah, so XY plane. Wow, what the hell is this? And then the Y axis, it just says set copies to 5. FT copies, and I set it to 5 and click generate. Geometry not selected, axis not selected. I like when such things happen. Look at. Okay, let's click on pattern, and for some reason it said that geometry was not selected. So let's show errors or warnings. Okay, undefined pattern axis, feature pattern 1. Copy paste something and pattern. Now why the hell am I not okay, I think I should just simply delete it. I'm really not good at troubleshooting these days, or right now I'm really not good at troubleshooting. Just create a new pattern. Yeah, so getting back to my senses. साइड हो जा भाई, थोड़ी जगह दे दे मुझे टेबल पे. Select the geometry and apply. And axis, click on the XY plane, then click on the Y axis and apply. Okay, I think copies 5. Now generate. Or what do we get? Wow, 1 2 3 4 5 6. Okay, so in total we get yeah, we get something over here. Yeah. Okay, so we need to understand. See, I understand extrude, and what's the purpose of creating a pattern? Okay, yeah. So we are creating a pattern of the geometry around an axis. Okay, yeah, that's how we should understand it. Now create the hub. From the create menu, select primitive. From the create menu, select primitives, and then primitives, and then click on cylinder. Okay, see, we're seeing something over here. In the details, you set the base plane to the x zx plane. Base plane, it is, oh man, how to change it? Base plane, zx plane. So do I need to like, do I need to do something like this? Oh yeah, simply just click on it. So yeah, base plane. Now we're creating a primitive cylinder. Now let's see what happens. I think it's gonna place a cylinder in the middle. Okay, set the following: origin x, y, and z coordinate as 0, which is actually 0, and oh no, we need to set the z as 50. X and y remain 0, and radius. Let's do it 50 again. No, not 50. I don't know why I'm so obsessed with 50. Let's do it 75. Uh, as thin surface, as thin or surface. Okay, if someone's got an idea, please let me know. Do I need to click generate? Yes. And yeah. Okay. Origin definition. Create a plane. Select the face as shown. Okay, now we need to create a plane. Select the face as shown and select the new plane button. Where is the new plane button? Details of plane 4. Select the face as shown. Select the new plane button. Where do I find the new plane button? It looks something like select the new plane button. I mean, dude, there are two types of planes. Yeah, revolve. Look at it. Aha. New plane. There is one button over here. Okay. I click on the new plane button and then I click generate. Okay, I think so. Maybe it generated a new plane for me. Okay. It shifted the plane. Oh, so this thing shifted the plane to the face I selected. Uh, to the face, the top face of my cylinder. uh, Create the shaft. From the create menu, select primitive cylinder and the details. Activate the base plane selection box and select the new plane you have just created in the tree outline. In the details, you activate the base plane selection box and select the new plane you have just created in the tree outline. Yeah, let me get back to my senses, guys. No, I don't know if this is going to be big or not. We've already lapsed 34 minutes. Yeah, but you should happily assume around. You should happily block 1 hour of your time for such content. In the details, you activate the base plane. Activate the base plane. How to activate? Uh, uh, okay. So, is there any other from no create primitives and then again cylinder? I have to select and in the details you activate the base plane. Activate the base plane to what? Oh, okay. The base plane is the new plane I have, and click plane 4 because that was an apply. Okay, so let me read it out. What's said over here? In the details, you activate the base plane selection box and select the new plane you have just created in the tree outline. Apply the selection. Set the following coordinates in origin XYZ is 0. Oh my god, I think I've done something terribly wrong over here. Okay, Z component, axis Z component, it was 50. Why did I do it 30? Radius is 75. Origin and axis. Oh man, it was 50. Okay, first of all, generate a some big problems over here. And can I undo it? No, I cannot. No, um, let's delete this. Okay, just for cylinder one, just do it 50 and click generate. Okay, yeah, we've just made it white. Uh, Now again we will create a cylinder. This is the best thing I like, reverse engineering. Create another cylinder. Can we rename it like cylinder 2? Rename cylinder 2 please, because it's automatically rename it the next consecutive number, and that's going to show my lags. It's going to show that I've already committed a mistake. My x, y, and z coordinates are 0. X and y component I hope I'm seeing the right z. uh, oh no, guys, 1 second, I think I've lost track. Primitive. Yeah, no, I've not lost track. 00550 and radius. Yeah, next what we need to do is, yeah, base plane selection and select it to plane 4 and apply 000. Everything was 0 here. X coordinate and y coordinates were 0. Z axis component was 550 and radius was 15. 550, radius is 15. I don't know why I'm talking like in past tense. Click generate. Wow. Just select the XY plane and look at it. Okay, so I've created this on top of this. Good. It's like plane selection and moving around, playing around with planes. Okay, this completes the mixing blade assembly, but somehow in our case it did not. And that's bad, because I think this entire thing should have been submerged or like blended into the blades, but it has not. I think we have committed some mistake over here. Yeah, no pattern, it's right. Set to 5 copies. Select set at 50. It's ZX plane. Yes, it is that explain. So, guys, let's troubleshoot this. We are having an issue over here. I think so. There is. Mm, the radius is somewhat. Z component is 50. I think. Uh, so you first create the pattern, then we create the cylinder. Okay, just I need to find a better angle. Guys, let's hold on. Maybe you can skip the video further, but I don't think so. If you take time, because something's not right over here. This thing should have been blended into it perfectly. Primitive. Okay. I create a pattern. Geometry on body. Copies 5. In the details view, set the base plane to the ZX plane by selecting and blood. What the hell is this up to? As thin surface. Okay, add material coordinates. Yeah, it is coordinates. FT00. Oh, yeah, this needs to be 0. As I know, I have committed some mistake over there. Yep, yeah, we are done. See, so yeah, our origin coordinate was also having some value. It should be 0, perfect 0. Now, let's this next. Now let's review it. One part, one body, and one solid. It's the way I like it. Now preparations, and how many pages have we covered? We have already covered 23 out of 40 pages of this document, and things from here are going to go much more quickly. Don't worry. We'll now create the outer body of a tank using a primitive cylinder and apply blends to the upper and the lower edges to create the fluid. Uh, uh, to 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 create the fluid. Uh, to create the fluid domain, the blade assembly. Uh, will be subtracted from the outer body using a boolean operation. Okay, so primitive cylinder, then we have some blend, then boolean subtraction and fluid domain. Okay, so primitive cylinder, in the details you activate the base plane and select the ZX plane. ZX plane, why are we so much obsessed with the ZX plane every time? Okay, yeah, to add frozen. So let's go to create another not chamfer. We need to create primitive and cylinder. Where's the cylinder? It will get generated, don't worry. And select the ZX plane, set operation to add frozen. ZX plane we set here and add frozen. It looks like some ice cream operation. Set operation to add frozen and set the following: origin x and y and 100. X and y is 0 and 100 is minus 10. Let's be very careful about this because we have committed a mistake before. X and y is 0 and z is minus 100. Let me re-verify it. And axis x and y is again 0 and uh, okay, yeah, uh, everything else is 0 and this is 700 and radius is 300 mm. Thin surface, and I see something over here. Click generate. Yeah, yeah, somewhat. Let's look over it. Yeah, radius 300 mm. Okay, now blend. Select fixed radius, plan, and in the details set it to 100 mm. Activate the edge geometry and select the edge selection filter. Select the two edges bounding the top and the bottom. Control click for multiple selections and apply the selection in the details view and click on generate. Okay, so it's a pretty simple fixed radius. We'll create, and what's the radius given? It's 100 mm. 100 mm is 10 centimeter. Yeah. So now geometry. I will select the edge 1 and 2, and I will click apply and oops, did it do the right thing anyways? Yeah, I do not need to select the edge. Okay, it's just for comfort. You don't need to select this edge selection filter. It's just for comfort. If you have a really good precision in your mouse and your hands, yeah, you're going to do it anyways. For multiple select, and we have done it. Now, now we'll do some boolean subtract. Now, subtract the blade assembly from the outer body. Select boolean from the create menu. Subtract the blade assembly from the outer body. Blade assembly from the outer body. Subtract the blade assembly from the outer body. Subtract the blade assembly from the outer body. Okay, boolean create boolean. I No, it is somewhere over here. No. Yeah. In the details view, operation unite, now subtract. Now activate the tool body and select the blade assembly. Activate the something's funny around there. Activate the tool body selection box. Tool body. Okay. And select the blade assembly. And select the blade assembly. You can do this from the tree as shown, but yeah, I think so from the pattern. Whoa, it selected 5 blades, but not the 6th one. Activate the oh, we had yeah, yeah, that's how it should. Uh, we include the blend as well? Has it included it? Yeah. And click apply. And what the hell was that? Click apply. Still it says not selected. Anyways, activate the target body selection, select the outer body. Target body, select the outer body. Apply. One body. Tool bodies, select pattern. And guys, and if I click on apply, it still says not selected. It still says not selected. And tool bodies, pattern. How should I? Aha, okay. I need to select, I think so, everything. Or maybe I need to select sketch 1. What is sketch 1? What is sketch 1 over here? Select tool bodies. Okay. Uh, there are certain cylinders over here. I don't know why. Tool bodies, and I select cylinder 4. No, I don't need to do that. Cylinder 2, cylinder 1, and pattern. And extrude, have blend. No, and apply, and it should give me the same thing. Yeah. So again, we are in a situation where we do not exactly understand. Set preserve tool bodies to no. Tool bodies. I need to select this assembly. Where do aha, maybe it is this solid. Yes. And apply. Yes. Okay, this is one entire solid. But I really cannot recall when we made it one entire solid and when we started considering these three pieces as one single entity. Okay, select to no and then create generate. Now these two things are different things now. Okay, preparation planning. Uh, Now we need to create a separate zone surrounding the rotating blades. This will be used in simulation to specify rotational motion. Uh, so must be separated from the rest of the fluid domain. A cylinder will be sliced out of the fluid domain, leaving two bodies. So inner rotating zone, slice cylinder, outer zone. Create the rotating zone. From the create menu, select primitive cylinder. From the create menu, select primitive cylinder. Okay, primitive cylinder. I just remembered something and started laughing to myself. Cylinder. Again, select the Z explain, because this is the plane we like the most. It's not that we like it the most, it's the thing that we are doing. Apply the selection, select operation to slice material. Whoa, when? Operation to slice material. Set the following. Okay, it's 0, -20, 0, -20, 0, and 90. Okay, 0, z axis coordinates, it's -20, and may I know why? Okay, yeah, I understood. And I need to make you guys also understand. This is because we need to have a separate zone that would include the region with this, flat cylinder and the blades. So we need to start from -20 on the z-axis. We need the bottom of our cylinder to be located -20, -20 coordinate on the z-axis, and for axis it is like, for both of them it's -20, x and y is 0, and z is 90. I'm still having a bit of confusion here. What are we exactly doing? I know what are we doing, but how is this thing relating to uh, our final result? 170, and generate. Yes, we get what we wanted. uh, Now set the, we get two bodies, two parts, both of them solids. In the triangle, select the body, both bodies. Okay, in the details we select the fluid, solid assignment to fluid. In the details view, and select this to fluid. Now, this leaves two bodies which together as separate parts complete the model. Okay, now now we'll now parameterize the model such that the blade angle and the radius can be changed. Okay, we need to make the radius of the cylinder forming the rotating zone as a function of the blade radius. Okay, we'll need to make the radius of the cylinder forming the rotating zone a function of the blade radius. Changing the blade radius, blade angle, and radius using parameters. Okay, parameterization. Okay, we've got only 10 pages left, and don't worry, I think so it will be completed in 1 hour and 15 minutes, 1 hour and a quarter. Parameterization, the dimension defining the blade angle. In the tree outline, select sketch 1. Okay, I've selected sketch 1. In the details view, check the box next to the angle dimension as shown. Check the box next to the angle dimension as shown. Enter the name blade angle in the parameter dialog box. Okay, blade angle. Okay, well, it was not said that. Okay, so you see, we have clicked, as we have clicked it and renamed it, a P symbol has appeared in the square box, indicating that this is a parameter now. Here in this case D is appearing, but in our case P is appearing. Interesting. Parameterization, parameterize the dimension defining the blade radius. Parameterize the dimension defining the blade radius. In the tree outline, select extrude 1. uh, Parameterize the dimension defining the blade radius. In the tree outline, select parameterize the dimension defining the blade radius. Okay. Yeah. Parameterize the dimension defining the blade radius. What was that blade radius? Extrude 1. Okay. Uh, Select extrude 1, and in the details view, um, row, I've selected extrude 1. In the details view, check the box next to the depth dimension as shown. Depth dimension. Yeah, it is it. Blade radius. Click over here and blade radius. And click OK. Parameterize the dimension defining rotating zone radius. Rotating zone radius. And what was that rotating zone? It was cylinder 5 in our case, and it is a solid cylinder for some reason, and it should not be. Okay. R zone radius again, like do the same thing, but it's radius. uh, R zone radius. uh, uh, Enter. uh, okay, so okay, we've set up the parameters. I was just like figuring out things in my head. Only 8 pages left. We are done almost. Enter the parameter manager by click on the button on the toolbar. We need to parameter dimension assignment, design parameters, print preview. Where is the parameter? There is not even a search here. Oh man, what is this? Display direction, multiple, triple, double, single, free. What's this? What is this? False. Edge coloring, face coloring, by thickness, by body color. Horizon radius, I've already made it a parameter. Okay, so I don't need to do it again. Enter the parameters manager by clicking the button on the toolbar. Oh yeah, okay, yeah, here I see it. 150, 170 length, angle. The first box. The first box lists the parameter we have created and the current values. Enter the parameter dimension assignment. Enter the parameter dimensions assignments. Enter the parameter dimensions assignment box by clicking the tab as shown. Okay, I show you how it's shown. Click cylinder for FD dimensions is cylinder 5 R zone radius. Okay, click cylinder 4. In my case, it's cylinder 5, okay? We created a wrong cylinder, if you remember. And I could easily rename it, but who will take the pain? Uh, Dimension is currently set to value cylinder 4.fd10. What is this fd10? Dimension is currently set to the value of parameter r zone radius. Yes, it is selected. Set cylinder 4 as equal to at the rate blade radius plus 20. Can I change it? Wait, blade radius plus as shown. Typing into the box and press check. Yep, yep. Test parameter functions. In the design parameter box, change the value of blade angle to 10. In the design parameter box, change the here it will go to 350, okay, not 10. Blade radius to 170. Since R zone radius is now a function of blade radius, since R zone radius is now a function of blade radius, you can now delete it. I deleted it, but it delete row. Yeah. Click the checkbox. I hope everything turns out. The function is evaluated. The first line details the value of the dimensions, defining the radius of the rotating zone as being the blade radius plus 20. So let this ensure a constant 20 mm gap. Aha, okay. Yeah, so we need to have some gap of 20 mm. The function is evaluated. The first line details when the check tab is selected, test parameter function. The model will require regenerating to the new parameters. When the test, the blade angle and the blade radius and the blade of the rotating zone are updated. Parameters and workbench. Switch to the workbench project page. Switch to the workbench. I think I'm also tired. It's been 1 hour 8 minutes, but we're just at 5 more pages. Believe me. Parameters in workbench. Switch to the workbench project page. Okay, we had workbench over here, and we have parameters. Either double click and double click the parameter set box. In the table, yeah. So now we can set here some parameters. See, in the table of design points, change the parameters back to 1 to 20 and 150. Okay, so R20 looks like 340 for some strange reason. If someone understands it, please let me know. Change it to 150. Click on the project tab. Okay. Were we supposed to click on enter? Has it retained the value? Yeah, it has. So click on the project tab. Right click on the geometry cell and click update. This will send the parameters value from workbench to the design model and update the geometry accordingly. Oh, like I can always change my geometry. It's like dynamic geometry. Wow. Design modeler does not need to be open as during a complete system workload. This design modeler does not need to be open at this moment. For demonstration purposes, switch back to the design modeler application to check the updated geometry. Next slide. Let's see. We were asked right click here and then update. What's happening? Oh yeah, I think so. It's done. And open design modeler. Yep, I see something weirdo. Save the project. Yeah. This completes the workshop, or as I call it, discussion. From the main menu, close. Save the project is complete. From the main menu, Workbench will save any application data. Yeah, so it's the job of the Workbench, not the design modeler. So if I click on save as, and I had something like my tutorials. Who's calling me? And uh, let's call it. What was the name? Mixing machine or what? Ah, what was the name? Creating tank model. Save. It's gonna take some time. Save project. Okay, so uh, two and pages are remaining. So yeah, what we have accomplished uh, in this discussion is like to set the dimensions as parameters and keep on dynamically updating the geometry, creating a mixing tank model, obviously. Now we have two optional challenges over here, but honestly speaking, I don't think so. I have enough strength and time left. It's already 1 hour 30 minutes. But let's read the challenges. Uh, let's see if we could. Uh, I'm even running short of words. If we could do anything to realize them. Open parametric workshop challenge. Parameterize its dimension to height such that the volume remains constant. Uh-huh. Okay. So the first challenge is we need to parameterize the height with the volume and height with the diameter so that the volume remains constant of the entire system. Create a relation between number of copies and pitch angle so that the pitch angle parameter is driven by number of copies. Okay. Okay, so it will really require some effort, if not a lot. So maybe I'll create a playlist and add the optional challenges problem being solved into the same into this current geometry that we have made, and maybe add it as an add-on. Okay, so let's leave it here. See you next time.